All right, so chapter 6 is counting principles, basically the beginning of, getting ready for statistics stuff. So a lot of you have seen this before, some from stats, geometry, did a bunch of this stuff, maybe one of the other math classes. So counting principles is just an organized way of figuring out what the possibilities are. So number 1 says this summer the library has choices for remodeling. They can either paint or wallpaper. So those are the two options for, the walls. You're either going to paint the walls or wallpaper. And then you're either going to do carpet, tile, or hardwood on the floors. Okay? So, there's a lot of different ways you can do it. You can just make a list. Some people like to make a box. There's not a lot of space. I'll just kind of do it up here. Some people like to make something like this, and go, wall here and floor here. And the wall you could paint or wallpaper. And then your floor would be either carpet, tile, or hardwood. Carpet, tile, or hardwood. Something like that. It doesn't matter. However you want to organize it so that you understand what's going on. But basically, you have two choices. First off, you're going to either paint the walls or wallpaper the walls. So that's two choices. But with each of those two choices, you have three choices. You can do paint with carpet, paint with tile, or paint with hardwood. And then you could do wallpaper with carpet, wallpaper with tile, wallpaper with hardwood. So basically, you're looking at a 2x3. 2 choices by 3 choices. And some people like to, you don't even have to make a table. You could do this. You can say, hey, the wall is 2 choices and the floor is 3 choices. Either way, it ends up being 6 possibilities. Okay? All right. For bedtime, I have a choice to wear. Okay? So I'll do it a different way this time. What am I wearing? Let's just be a W. All right? What am I wearing? I could wear either a flannel nightgown, a robe, long johns, or my Batman cape. Okay? So in other words, I have a choice of wearing 4 different outfits. This is just a different way to organize it. You do whatever's comfortable for you. For footwear, so feet. For footwear, I have bunny slippers or fuzzy, with a Z, socks, with an X. Fuzzy socks. Which means I have 2 choices of footwear. And my bed covering. I can use an electric blanket or a comforter. So my cover, I have 2 choices. So what are the different combinations? I could wear a flannel nightgown with bunny slippers and an electric blanket. I could wear my nightgown with fuzzy slippers or the comforter. That's one possibility. And I could do the nightgown and the socks and the blanket, or the nightgown, the socks, and the comforter. That's another choice. I'm not going to run through them all, but you see how it plays out. But instead of making that chart, that huge overflowing chart, you just actually take all your possibilities and you multiply them. So 4 times 2 times 2 is 16. So you have 16 different combinations that could occur. Now, don't write this down, but I'm going to, if you remember this thing called a tree diagram, you'd have something like this. What am I going to wear? Well, I could wear my fuzzy nightgown. I could wear my robe. I could wear my long johns, or I could wear my Batman cape. Then I have 2 choices of footwear. So you do this. And the problem with these things is it gets really messy and really kind of cramped. And then I have 2 choices of bed covering. And it gets really hectic and busy, and it's, this is without writing words in. Oh, what a mess. But basically, you would end up with 16 different choices at the end. You save all that trouble by just doing the math of the counting principle. The counting principle basically just says, each choice, multiply them out. Just makes life easier. All right? Number 3. 9 girls are running for prom queen, and 7 guys for prom king. How many different possibilities are there of couples? Well, again, you got your queen, 9. You got your king, 7. 9 by 7. There are 63 possible couples that could come out of that arrangement, depending on who won which category. And again, if you made a tree diagram, that'd be just absolute nightmare because you'd have to make 9 branches for each queen. And then off of each of those branches, you'd have to do 7 there for each king, and it just gets messy. So counting principle just makes life a whole heck of a lot easier. All right, 8 athletes are racing on a track. How many different ways could they finish the race? Now, the way I like to do these when you have this situation is you got 8 athletes. So you have 1, 2, 3, 4, 5, 6, 7, 8. Okay? How many different ways could they win the race, finish the race? All right? Let's say we're going first to last. Okay? How many people are there that could come in first place? Well, there's 8 of them. All 8 have the chance of coming in first. Once someone comes in first, and we're not going to have any ties, once someone comes in first, now there's only 7 people left to come in second. Once those 2 have finished, there's 6 people left for third, 5, 4, 3, 2, and obviously there's only 1 person that would end up last. And then all we do is multiply those numbers, and we get 40,320 different ways the race could be finished. Which just seems insane. That huge of a number with only 8 people, but mathematically that is a possibility. Because you have 8 choices for the first place, and then off each of those branches, you have 7 people that could come in second, and off of each of those 6 and each of those 5, it just gets out of control. So that's your possibility. How many ways could a gold, silver, and bronze medal be awarded to the first 3 finishers of the race? Okay, well, we have first, second, third. It helps the label. Go ahead. Whoops, that's supposed to be up there. That was silly of me. You're up here. Writing is hard. Now, this is still based on the 8 runners. So now we're basically only taking this section and moving it down here. So it's 8 times 7 times 6. Okay? So it's set up the same way, except we're only dealing with the first 3 places because after third place, there's no medals. All right? And that, if you multiply those, ends up being 336 different combinations. Which again, seems a little, like that many from just 3 places, but that is the math of it. All right. Carl Friedrich Gauss, Sir Isaac Newton, Leonard Euler, Archimedes, and Niels Hendrik Abel are running for president and vice president of the Math Council. How many different ways could they be chosen? Okay, so we have 2 slots. We have the prez and the vice prez. Well, let's see how many people there are. There's 1, 2, 3, 4, 5. So there's 5 people who could get the presidential spot. Once that person is elected for the president, there's only 4 people left for the VP slot. Multiply those, and that means there's 20 different combinations, possibilities for the president and vice president. So you can see the math here is pretty easy at the beginning. How many 2-letter initials of people's names are there possible? Okay, well, 2-letter initials. So we got first initial, second initial. All right. And there's 26 letters in the alphabet. And since you could have somebody JJ, you got 26 letters here because you can't have repeats. Now, if you could not have repeats, it'd be 2625, but that'd be weird, limiting someone, say, hey, you can't have that name. That doesn't make sense. So you do 26 times 26, which is 676 ways. So everything from AA to ZZ and everything in between, there's 676 different ways of doing that. Because you could have AA, AB, AC, AD, all the way down to AZ, and you could have AZ all the way down to ZZ, and everything in between. Number 8. We have 5 seniors, 4 juniors, and 6 freshmen. Okay? They put their names in a hat for a drawing. First prize is a bag of Skittles. Second prize is a bag of M&Ms. And third prize is a bag of Sweet Tarts. Okay? So, we have 3 prizes. First, second, and third place. The freshman names are secretly removed. How many different ways can the prizes be given out? So, if you look at this, we have 5, 4, and 6. So we have 15 names. But they secretly took out the freshmen. Sounds like something seniors and juniors would do. Which leaves only 9 people. So there's 9 people for first place. After that person is chosen, it's like we've already taught before. That leaves 8 people here and 7 people here. Multiply those 3 numbers and you get 504. Now, if the freshman had not been taken out secretly, that would have been 15 times 14 times 13. So a lot more ways. But this was a fixed race. All right. Last one in this section. In a beautiful daydream you frequently have, your parents offer you a choice of a birthday present. You can pick from 3 different Ford Mustangs or 2 different Corvettes. How many different ways can you make your choice? Now, the key word here is or, and we're going to get at that in the next section, but this is kind of a teaser. All right? You have a choice between 3 different Mustangs and 2 different Corvettes. You're only getting 1 car. Okay? Since it says or, it's basically saying there's 5 cars to choose from, and that's really all it comes down to. There's 5 choices. You can choose from the 3 of these or the 2 of those, which basically means they're saying, here's your 5 cars you can choose from. Okay? All right, now, getting into those key words, and or. Okay? Now, this is not a dead set rule, but it's most of the time. And implies multiplication, which we have been doing every example up to the last one, or usually implies addition. Okay? Which is why we just added 3 plus 2. We did not do 3 times 2. Okay. So, examples. The original Missouri standard license plate consisted of 3 letters followed by 3 numbers. Under this format, how many different license plates could be made? So again, I like to put 6 slots because there's 6 spots. Now, 3 letters. So these are my letters, these are my numbers. Okay? With that format, if I had 26 letters here and it's allowed to have repeats, you could have 26, 26, 26. Now, this one usually throws people off because most times they say 9 numbers. But you got to remember to count 0, so that means there's 10 numbers. And since you could have repeats, like 1, 1, 1, those are your possibilities 10, 10, 10. So, if you multiply those all out, you get, it's a crazy number, 1,576,000 different license plates. So everything from AAA 999 to ZZZ, same thing. And every combination in between. Now, how many license plates start with GAG? Okay, just that. Well, we're still doing the same thing, but if you're saying this is going to be a G, and this has got to be an A, and this has got to be a G, that's just one letter. So you're limiting the choices of letters by just saying 1, 1, 1. And then we have 10, 10, 10 for numbers. So if you multiply those, you basically get 1,000. Okay? So 1,000 different license plates that would have GAG at the beginning. Consequently, how many end in 782? Well, again, we do 6. But if I'm limiting the numbers to 7, 8, and 2, I'm saying that's the only number can go in that slot. Therefore, I have 26 times 26 times 26. If I multiply those all out, I get 17,576 different license plates, ending in 782. So if you think about, you see a cop show and they're like, did you get license plate? Oh, I just got the last 3 numbers, 782. That means there's 17,576 license plates that could match that car that was driving away. Or if you're like, oh, I saw GAG, but I didn't get the numbers. That means there's still 1,000 cars out there that would have GAG as the beginning, and then the numbers change. Okay? How many different 7-digit phone numbers are there possible to create? Now, this is kind of an old question because, well, back when I was a kid, there was only, 7. Then the 2 area codes came when I was an adult. Then it was 636 or 314. And then now with the new law, with the new phone number, now you have to use 314 or 636, So it's kind of gotten more complicated as it went along. But we have our 3, then we have our 4. So there's our 7-digit number. Okay. How many different 7-digit numbers are there possible to create? Okay. Now, this is just mathematically, not logistically. And it's just 10 times 10 times 10 times 10 times 10 times 10 times 10. Now, logistically, you'd have to go talk to the phone company and find out what the rules are. Like, I don't think you can have 0 as the first digit. So therefore, it would have to be, this number here would actually be 9, not 10. Okay? But just based on this, we're just going with logistic mathematical. You're doing 1, 2, 3, 4, 5, 6, 7 zeros. So, I did not mean to put that comma there. It's 10 million combinations. One with 7 zeros. Now, is that technically true? Probably not. Okay? Because you can't have 0 as the first number. There might be some limits on what can be in the first 3, per se. But not working for the phone company, I don't know. So mathematically, we're just talking about the outlandish possibility of 10 million different phone numbers. Now, not going to do this, but let's say we add area code like we have to nowadays. That would just be 3 more zeros. So 10 billion instead of 10 million if we add in the area code. All right. At a concert, the band will play 7 songs, 3 fast songs and 4 slow songs. If they agree to play a fast song first and a slow song last, how many different ways could they play in all? So, again, we have 7 possibilities. There's 3, 4, 5, 6, 7. So there's a song. Now, they have 3 fast and 4 slow. Okay? But they said they're going to play one of the fast songs first. They only have 3 fast songs. And they're going to play one of the slow songs last. So we have to put those in first. Now, that means there's 5 songs left. They don't have any order, they said, outside of this. So their second song, basically, after they play that fast song, and they know they gotta save a slow song, that's 2 of their songs locked in. So that means there's 5 songs left. Well, after they play that, then there's 4 songs left, and 3 songs left, and 2 songs, and 1 song. Which means there's 1,440 different ways. All right, so you have 5 girls and 5 boys. You're going to have their photo taken together. They'll line up in a row. So again, that's 10 spots. So really easy. We just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how many spots we have. Okay? And we got our 5 boys, 5 girls. That's 10 people. It doesn't really matter boy or girl, it's just 10 people. So there's 10 people for this first spot. Once they're in place, there's 9 people for this one, and you kind of get the drill. 7, 6, 5, 4, 3, 2, and then obviously there's only 1 person left for that last spot. Okay? Now we multiply that out, we get 3,628,800 different combinations of pictures. So just from 10 people, there's 3.6 million different ways that photo could be taken. It's kind of crazy how the numbers shoot up so fast. Now, what if we have this more specific situation? How many ways can the photos be taken if the girls must be next to each other and the boys must be next to each other? Okay? Well then, if you think about it, there's still got the 10 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you got your 10 spots. Okay? But 1, 2, 3, 4, 5. You basically have to have your girls all right here. 5, 4, 3, 2, 1. And your boys 5, 4, 3, 2, 1. Okay? Because the girls have to be in a group and the boys have to be in a group. And if you do that, that gives you 14,400. But that's not the only possibility. Because, let's say this is the girls and this is the boys. Well, then you have the exact same situation where that's one picture, all the girls on the left side and the boys on the right side. But what if you switched it and had the boys here and the girls here? Well, then that's another 1440. We don't have to waste time writing that all out, or we can just double it. Now, obviously, we could draw all the slots again and fill in the numbers, but you kind of get the gist. Basically, you have the girls and the boys, so that's 1440 times 2, so that's 288,000, or 28,800. So if you had all 5 girls, then all 5 boys, or all 5 boys and all 5 girls, those are your possibilities. 28,800. All right. Then, how many ways can the photo be taken if they must alternate gender? So again, we got our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. And so there's got to be girl, boy. Then there's 5. Okay. But if you think about alternate, then the 4 is here, the 3 is here, the 2 is here, and the 1 is here. And then you have the girl, 5, 4, 3, 2, 1. But a girl, again, we got to look at that as, like, let's say we started with girls in this one. We'd have to do it all over again for boy being first. So girl, boy, girl, boy, girl, boy, boy, girl, boy, girl, boy, girl. So when we multiply this out, all right, now, the same thing is going to happen. Okay, the same number is going to be there because you're still doing 5, 5, 4, 4, 3, 3, 2, 1. This is still going to be the same. So it's going to be 14,400 times 2, 28,800. So you get the exact same number, regardless of whether you have the girls grouped and the boys or you're alternating. The math is still the same because there's a specific requirement there. And the last example. Two married couples go to a movie. How many ways can they sit next to each other if order doesn't matter? Okay? So, two married couples, that means there's 4 people. Okay? So we have 4 slots, and that's simply 4, 3, 2, 1. So that's 24 ways. No order, just whoever sits wherever. How many ways can they sit next to each other if husbands are on one side and wives are on the other? Well, again, we have this. Let's say this is husband and this is wives. That's 2, 1, 2, 1. So that's 4. But if we also put the wives on the left and the husband on the left, we'd have to multiply this by 2. So there's 8 ways. And again, if you want to show the work, you would just do it like this, where you put the wives first and the husband second. 2, 1, 2, 1. 4 and 4 is 8. Now this next one's kind of tricky. How many ways can they sit next to each other if spouses must sit next to each other? So there's 4 people, so that's obvious. 4. The next number is kind of tricky because you can kind of reason your way through it. But if you think about it, if spouses must sit next to each other, this person's spouse has to sit there, so there's really no choice. Whoever sits first, the spouse has to be there, so that's 1. And this next number is tricky too because you gotta think about 2 spots are filled. So this is not the number 3 here, this is number 2 because 2 people are seated, 2 people haven't seated, and then again, that person's spouse has to sit there. So this is also 8 ways. And that's it.